Okay, so this is Thursday's CER. Now the problem says the perimeter of an equilateral triangle is equal to the perimeter of a square. It also tells us that each side of the triangle is 3 inches longer than each side of the square. Now, in a square, the definition of a square is that all 4 sides are equal, right? 4 90-degree angles and all 4 sides are equal. So this is X. Each side is the same. And for my triangle, each side is 3 inches longer than each side of the square. So the perimeter of my triangle is equal to the perimeter of my square. So the problem does not have to provide us with a picture. We can create our own. So now perimeter is side A plus side B plus side C. This perimeter is equal to this perimeter, side A plus side B plus side C plus side D. So here's the equation for this problem. Now, I'm not going to take it further than this. You guys know how to combine like terms, and then from there, how to use inverse operations to isolate the variable. So I'm going to give you time now to work on your CER. Okay, if you are in 7 Accelerated, we're working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 4.2, example 1, and we are on page 150. Okay. So today we're going to be talking about the slope of a line, the upness and the downness, the diagonalness of a line. Okay. So we have a graph and we have a line that is going up. So like your grades, so if the line is going up like your grades, that is positive. So if the line is going up like your grades, that's positive. We like lines that are going up. That's positive. But unfortunately, like some of your grades, the line is going down. So if the line is going down, like some of your grades, that is negative. So if your grades are going up and the line is going up, that's positive. If your grades are going down and the line is going down, that's negative. So we have positive slopes and we have negative slopes. So let's talk some more about slope. So this point is -3, 2. Then we have -1, 0. Then we have +1, +2. And we're going to connect these points. They're points, not dots. Do not call them dots. They get offended. They are points. So when I look at this line, the first thing I notice is it's going up. Like I want my grades to go up. So we can say the line is positive. So the first thing we know is our line's positive. Okay? The slope of our line is going up. It's positive. Let's talk about this slippery thing called slope. Slope is equal to the rise over the run. Rise over run. Well, what exactly does that mean? Rise is the up and the down. The run is the side to side. So I want to find two clean points. And a clean point is where it's a clean intersection right here. So it's where your X and your Y axes, your lines, cross in a clean point. So a clean point is where your X and Y cross and it is on the point. So this here is a clean point and this is a clean point. So we're going to go rise first, my up and down first. So I am going up. I went up. Up is positive. I went up 2, +2. So my rise is +2. It's positive because it's going up. And we went up 2 spaces, 1, 2. Now we're going to take a look at our run. Our run is side to side. So my run, I'm going to the right, which is positive, 1, 2. So my run is +2. So +2 divided by +2 is +1. My slope is equal to +1. So my rise is the up and down. My run is the left and right. And we always, always start with rise. It makes life easier. So if we're going up, it's positive. And if we're going down, it's negative. Okay?
I have a question. How do you know how many to go up and how many to go rise? Like how much to go up and how much to go to the side?
So here was my point, and these are my marks on my graph. So I picked a point and I went up to my next point. I'm making a triangle. So here's a point and here's a point. I'm going to run up to my next point or to whatever clean point I've highlighted. So I'm running up and I'm going up 1, 2, 1, 2. And here's my next clean point. So then I move to the right, 1, 2. So I'm going up or down to my next clean point. We'll do another one. Let's do another one.
Like, is it a fraction like turned into like the rise and run thing?
Yes, rise over run is a fraction.
Okay.
So rise over run is a fraction. Let's do another one. So my first point is negative 3, 3. My next point is negative 1, 2. And my next point is 1, 1. So this is where having grid paper is helpful. Not necessary, but helpful. Okay, a clean point is where your X and your Y cross. It's a clean point where the X and Y cross. It's not in between points. It's not fraction or a decimal. We try to make it whole numbers to make it easier to work with. So I'm going to pick 2 clean points. And it doesn't matter which 2 points I pick. They don't necessarily have to be next to each other. So here's my 2 clean points. And I know that slope is equal to rise over run. And yes, that is a fraction. So here's my 2 clean points, and this is where they come together. So I'm going down. Down is negative, and I'm going down 1, 2. So my rise, because I went down, is negative, and I went 2 spaces, negative 2. Now my run, I'm running to that point. So my run is to the right, it's positive, and it's 1, 2, 3, 4. I ran positive 4 spaces. So I went down 2 spaces and then to the right 4 spaces to get to that next clean point. So negative 2, positive 4, my slope is negative, and 2 over 4 is 1/2. So my slope is negative 1/2. And that looks to be true because the slope is going down, like my grades. The slope is going down, so my slope is negative. And what this is telling me is that for every, let's see, my grade goes down 1 letter grade every 2 days. So I'm going down 1 letter grade every 2 days. Down 1 letter grade every 2 days. Down 1 letter grade every 2 days. So that's what my slope means. I'm going down 1 letter grade every 2 days.
What
It's
is
not looking pretty. What was that, Alvin?
What if the run is negative? Does it go
Okay,
to the left?
Can you go
What
to the
if,
left?
yeah, if it's negative?
Typically, you do your rise first. So you're going up or down first. And if that's the case, you're always going to be moving to the right. See here? I went up first and then to the right. So my slope was positive. Here, I went down first and then to the right. So if you do your rise first, your up or your down first, your run will always be to the right. So if you do your rise, up is positive, down is negative. If you do your rise first, your run will always be to the right. Okay, but sometimes they ask us, what is the slope of a line that passes through the points -3, 3, and 1, 1? What is the slope of a line that passes through the points -3, 3, and 1, 1? Well, we already have the graph for this problem. This is the graph for this problem. So I can create a graph and plot these 2 points, -3, 3, and 1, 1. And then I can do rise over run. I can count my rise, which was -2, and count my run, which is +4. I can do that. But there is another way. We can say slope is equal to the change in y over the change in x. Huh? What does that mean? Change in y over change in x? Well, it means y2 minus y1 over x2 minus x1. And you're looking at that and you're thinking, okay, that's dandy. But what does that mean? Well, we can label our points. x1, y1, x2, y2. So now it's just a matter of substitution. y2 is 1 minus y1, which is 3. Okay, not too bad. x2, which is 1, minus x1, which is -3. So we're just substituting them in. Let's bring this around. So 1 minus 3, 1 minus 3, this is where knowing your negatives and how to use those negative integers, negative operations comes in. 1 minus 3 is -2. And now I have 1 minus -3. I can change both of those, change it to an addition problem, change the sign of my second number. So now I have 1 plus +3 is 4. Oh, would you look at that? This looks like this. Interesting. So I have a negative and a positive, which is negative, and 2/4 can be reduced to 1/2. So my slope is -1/2. So we have 2 ways of finding slope. We can pick 2 clean points and count our rise over our run. Or we can use 2 points that they've given us and know that it's change of y over change of x, which means y2 minus y1 over x2 minus x1. We have to label our points and substitute, and it gives us the same slope. Okay, do not freak out about this. We're going to do a couple more examples. Let's do a couple more examples. Okay, so my first one says, what is the slope of a line that passes through 0.34 and point -3, -1? What is the slope of a line that passes through 0.34 and -3, -1? Well, the first thing I can do, I can create a graph and I can plot these points. And I'm thankful they're using little numbers because it makes it easier to create the graph. So they've given me 2 clean points. This is a clean point and this is a clean point. And I know that slope is rise over run. So when I want these 2 points to come together, it's going to be right here. So I'm going to rise. Now, because I'm going up, my line is positive, and I went up 1, 2, 3, 4, 5. So my rise is +5. Now I'm going to do my run. I'm running to that point. I'm running to the right, which is positive, and I went 1, 2, 3, 4, 5, 6. I ran to the right 6. So my run is +6. So my rise over my run, my rise over my run, my slope is +5/6. And that makes sense because my line is going up. The slope of my line is going up like my grades, and that's positive. So this is one way of solving this problem. The other way is to know that it's change in y over change in x. So I need to label these guys. x1, y1, x2, y2. So this is y2 minus y1 over x2 minus x1. Now it's basic substitution. y2 is -1 minus 4. x2 is -3 minus 3. So -1 and -4 is -5. -3 and -3 is -6. A negative and a negative is positive, and this can't be reduced any further. So my slope is 5/6. Okay, before we go, let's do one more example. One more example. And remember, the video is available to you to watch over and over again. If your video is off, you need to turn it back on, please. Stephanie, Mario, Ayana, and Mason. Okay, the question is, what is the slope of a line that passes through the points -2, 3 and 3, 2? What is the slope of a line that passes through -2, 3 and 3, 2? So the first way of solving this would be to graph it. -2, 3, and 3, 2. I'm glad they're using small numbers because it makes it easier to graph. So I'm going to go rise over run. And where these 2 points come together is right here. So my rise, I'm going down, which is -1. So my rise is -1. My run is to the right, which is positive, and I went to the right 1, 2, 3, 4, 5. So my run is +5. So this is telling me that my slope is -1/5. And that looks to be true because the slope is going down. That is a negative slope. Another way of solving this would be to label my points x1, y1, x2, y2. So my change in y is y2 minus y1 over x2 minus x1. So 2 minus 3 is -1. And 3 minus -2. I can change these to positives. So 3 plus 2 is 5. So would you look at that? My slope is -1/5. So you have 2 ways to find the slope of a line. You may graph it, or you may use the change in y over the change in x.